This is a recast of the 11,000-word piece, Bernard Baars' Insights into AI and Consciousness, from AI VIPs. Let's listen in.
Today's focus is on Bernard J. Baars, who was born in 1946 and is a well-known cognitive scientist and neurobiologist. He's been recognized for his groundbreaking work in the field of consciousness.
His career has spanned multiple disciplines, including psychology and neuroscience. He earned his Ph.D. in psychology from UCLA, and his contributions to our understanding of human cognition have been immense, particularly his work in cognitive processes related to consciousness, attention, and working memory.
Baars has held positions at prestigious institutions like the Wright Institute and the Neurosciences Institute. He is best known for formulating the Global Workspace Theory, GWT, a major cognitive framework that has shaped both consciousness studies and the development of artificial intelligence.
In a nutshell, the Global Workspace Theory postulates that consciousness arises when multiple specialized brain processes access a global workspace, a central hub where information is shared with various neural subsystems. This theory has significantly shaped discussions around how the brain integrates information and how conscious awareness emerges from cognitive functions.
Besides GWT, Baars' research also covers attention, working memory, and the neural mechanisms tied to conscious experience. His work has provided insights into how the brain focuses on relevant information while filtering out distractions. This approach to cognition incorporates ideas from distributed cognition, emphasizing how different parts of the brain work together to create coherent experiences.
Let's dive into the Global Workspace Theory, GWT, a bit more. According to this theory, the brain consists of a series of parallel processors, each responsible for specific tasks such as sensory perception, memory, and decision-making. These processors usually operate independently, with most of their activities being unconscious.
However, when information from one of these processors becomes relevant to our ongoing goals or actions, it is broadcasted to a global workspace. This global workspace functions as a central hub that lets different cognitive subsystems access and integrate information.
The process of broadcasting allows for coordinated action, decision-making, and conscious experience. Baars' theory suggests that consciousness is not tied to any single brain area, but rather emerges from this dynamic broadcasting system, a system where relevant information is accessible globally to a range of cognitive functions.
The Global Workspace Theory has been instrumental in advancing scientific understanding of consciousness. It addresses key questions, such as why certain cognitive processes become conscious, while others remain unconscious, and how different cognitive systems cooperate to produce unified conscious experiences.
The theory frames consciousness as a workspace for information exchange and offers a practical model for researchers. One of its strengths is its testability. Neuroscientific studies have shown that when people become consciously aware of stimuli, widespread brain activation occurs, supporting Baars' theory that consciousness is linked to global broadcasting of information.
GWT has also had profound influence on the study of attention, working memory, and perception. By proposing that conscious awareness arises from the global availability of information, Baars has reshaped how scientists conceptualize cognitive processes, positioning consciousness as an essential mechanism for coordinating complex mental activities.
But Baars' work doesn't just play a significant role in cognitive science, it has substantial implications for artificial intelligence as well. Specifically, the quest to build machines that can perform tasks requiring human-like cognition and consciousness.
One of the biggest challenges in AI research is creating systems that can perform complex computations but also integrate information in a flexible, coherent manner, much like the human brain does. GWT provides a potential blueprint for achieving this integration.
AI systems that aspire to model human cognition can benefit from the principles of GWT, such as distributed processing and global information sharing. By using the GWT as a framework, AI researchers can design systems where different specialized components, like those handling perception, decision-making, and learning, work in tandem through a global workspace, simulating conscious-like behavior.
This approach could lead to advances in AI systems capable of dynamic learning, real-time decision-making, in more intuitive human-AI interactions. It's even inspired cognitive architectures like LIDA, Learning Intelligent Distribution Agent, which attempt to model conscious processes in machines.
The influence of GWT has also been seen in other models like ACTAR, Adaptive Control of Thought Rational, and SOAR, both of which share principles with Baars' theory. These models have contributed to advancements in AI systems' ability to handle complex decision-making tasks.
What's interesting about GWT is its application in various domains. In healthcare, for example, AI systems modeled on GWT principles could help doctors diagnose diseases by analyzing large datasets and supporting medical decision-making. In education, GWT-inspired systems could enhance personalized learning by integrating data on student performance and tailoring educational content to fit individual needs.
As we look to the future, the question remains, can an AI system ever truly possess consciousness? This is one of the most debated topics in both cognitive science and artificial intelligence. While GWT provides a framework for simulating consciousness, it doesn't necessarily imply that machines would experience subjective awareness.
Some researchers argue that implementing GWT in AI systems could lead to functionally conscious machines capable of behaving like conscious humans. However, others contend that simulating functional aspects of consciousness isn't equivalent to creating subjective experiences. Therefore, whether functional consciousness is sufficient for true awareness, or if subjective experience is a necessary component of true consciousness, still remains up for debate.
The development of AI systems that mimic or potentially achieve consciousness raises several ethical considerations as well. If AI systems can simulate human-like awareness, questions arise about their rights and responsibilities. Conscious AI could challenge existing hierarchies in employment and redefine the concept of companionship.
The notion of controlling a conscious entity could be viewed as morally problematic as well. These moral and legal challenges will need to be addressed before conscious AI systems become widely adopted. Regulations might need to ensure that conscious AI systems are not exploited for labor or other purposes without consideration of their well-being.
In conclusion, Bernard Baars' Global Workspace Theory has left an indelible mark on both cognitive science and AI research. As AI systems advance and move toward more human-like capabilities, GWT will remain a critical framework for understanding and guiding the development of intelligent, potentially conscious machines. But as we venture into this new frontier, it's crucial to carefully consider the ethical, philosophical, and societal implications of creating AI that blurs the line between machine and mind.
That's it for today.